So for connecting buildings, I was looking here more what is the mainstream, what has to be considered, and what good recommendations can we give everybody as an operator, what technology shall be chosen. So my choice was here on complementing FTTH with FTTB, fiber to the building, by using mainly G.fast DPUs, but I will spend one slide as well on layer 2 access switches as alternatives. And I will explain later why I'm doing this. The drivers, of course, are clear. Everybody wants to get more bandwidth, deliver more bandwidth.
Norbert,
Yeah?
excuse me for just a moment. If you can put it into presentation mode, it looks like for some reason we're still seeing all your slides.
Okay.
On the lower right there. I think it was, maybe it's just not going into presentation mode because you clicked it, but it still looks the same to us. So sorry about that. We'll
yes.
just
what can I do?
Oh, there you go. That works. That helps.
Yeah, it's maybe
Thank
small.
Sorry to break the flow there.
No problem. No problem. So yes, main topic is to achieve higher bandwidths, both to offer attractive service offerings to customers, to fulfill the broadband target set by the regulators, by competition as well, and own strategy decisions. So bandwidth together with latency, for instance, but then as well, modern times require modern management systems. So it's quite important to increase the reliance on the cloud as well, to make use of the cloud, different tools this provides. And then last but not least, of course, it's exponentially increased in number of types and connected devices that puts another dimension to the technology that is chosen inside the buildings. So I am starting with a big picture here. What technologies are mostly used for connecting inside the buildings? What choices can we think of? Of course, the best thing, a lot of recommendations are around this, is to go directly to PON wherever this is possible. Of course, beside PON, FTTH with active Ethernet, point-to-point, could be another reason to be chosen here. For depending, of course, if it's residential, you would go mostly for PON. For business, there might be some requirements to go for point-to-point. But these are the mainstream technology, quite well known to everybody, I think. But then the complement is to do fiber to the building, which means there is a fiber to the building, but then of course you need some in-house distribution. And this could be done by several technologies, mostly depending where you're coming from, what is inside the house, how old is the house. Often we can find twisted pair in several countries, we can find coax. Of course, there's power line as one option, HN is one choice. There has been a time where people laid in Ethernet cables. Typically, this would be business buildings, for instance, or for small, medium enterprises, or as well privates that installed Ethernet cables because they found it quite nice. So here, in this case, layer 2 access switches could be used, and there are different flavors, different speeds, 1 gig, 2.5 gig, or 10 gig available that can be used. And then, of course, fibers could be used as well if you're already entering the different flats, units, or rooms with fibers. Here we have the old technologies like POLAN, which is basically, or fiber LAN, we call it, which is basically the passive optical LAN inside the building. It's called nowadays as well fiber to the room, where you basically put one mini OLT at the bottom of the building, and then you distribute via PON. You distribute the bandwidth and the connection to each and every flat in the building. POLAN or fiber LAN offers a nice thing that despite it's a PON, OLT, and ONT system, this is modeled as a similar like a Ethernet switch, so it can be very easily configured by people more familiar with types of switches rather than with PON OLT technology. And then last but not least, there is a special technologies as well, like hybrid fiber coax, where a combination of coax and fiber is used. Here we have DOCSIS 3.1 and DOCSIS 4.0, for instance, as technologies. And then the wireless technologies, including fixed wireless access, now of course using 5G, and then the satellite broadband with a very low orbit satellites. But these are special things which are maybe only applicable for certain regions. And of course, satellite is not necessarily inside the building. For inside the building, it's more the other choices that are mentioned here. So from this, I was looking, of course, here, what is a technology choice and what is the migration path that could be taken, because nobody wants to be stuck in old technologies or missing a migration path, or of course it has to be considered where are you starting from. So the technology usage is often dependent on what has been used before. So for instance, explaining this, if you were using copper-based access with VDSL, you might have the decision, yes, you could move directly to XGS-PON, next generation PON technologies. But of course, the other choice is you could move to G.fast first, to advanced copper access, and then over to XGS-PON. And similar could be done with fiber. If you have been using GPON, it's of course a native step then to move over to XGS-PON, to the advanced fiber access. Or what is here shown with the DOCSIS, if you have a cable TV system using DOCSIS 3.0, of course, that could be the choice to either move directly to DOCSIS 4.0 or to do the intermediate step via DOCSIS 3.1. So, of course, then this is specifically, depending on the installed base. It's, of course, depending as well, what is your competition doing? What is the financing of the projects requesting, the banks or the investors? And, of course, your own strategy. What is the ISP strategy you're following in order to offer services? So some might go directly, others are using the intermediate step via the one or the other, like fourth generation technology. Looking at the parameters that are important for judging if a technology is suitable or not, I'm taking here the FTTH Council Europe broadband technology ranking, which was done back in June 2022, so some 2 years ago, but still valid. Of course, they are giving quite high rates, 30% here on the speed, upload and download speed. Of course, it's good to have a symmetrical speed. The next one is 20% for service availability, so robustness and resiliency to maintain the service. 10% go for costs for the brownfield, the installed base. What needs to be considered, and then also with 10% the latency, quite important. And then, of course, depending what you want to achieve with the network and where you're located, then there are other aspects. At the latest, I would put maybe here the 5G install readiness. OpEx, I think, is quite important from nowadays from operational perspective. Spending money and of course having the resources, the human resources, to do the network operations. So the different technical aspects and economical aspects are important. And here the FTTH Council was doing a ranking of the different technologies. In total, 10 parameters are leading to 10 different pictures here. I selected the top ones with a 30%, 20%, 10%, and some 5%. Severity or ranking. And the judgment was done here by the Council Europe for urban areas, for suburban areas, rural areas. Of course, the main conclusion is that FTTH with PON is the best technology to be chosen, followed short behind by point-to-point fiber. But you cannot always do this and achieve this. So in this case, there are the other technologies like fiber, FTTB, and then putting G.fast for in-house distribution, or reusing still copper like VDSL2, or hybrid fiber coax if you have been using cable TV network before. Or then easy installable is, of course, the fixed wireless access with 5G technology, achieving good rates. And then if you are at rural sites, especially, of course, there might be a really good reason to use satellite broadband. It's nothing, satellite broadband is nothing for the in-house, but the technologies already show us a way or the overview what technology can be used, how suitable is it, how mature is it. If you make the choice of technology, of course, you would like to be on the right path, on the right track, and have a migration path to future as well. So the conclusion from this pictures, taking FTTH, PON or point-to-point as master technologies, but for brownfield installations, there might be a good reason to use either G.fast if you used copper networks before, or hybrid fiber coax if DOCSIS if cable TV networks have been used before. And this putting in the picture that basically I wanted to highlight a little bit the G.fast solution, because FTTH with PON or point-to-point, most people know quite well. FTTB G.fast is maybe not that well known, because of course there is a move away from copper. But on the other side, you still have the installed base with the copper. Either you have it still in the networks, so there's a huge copper plant in the network itself. But at least inside the building, often the copper cables, the twisted pairs, are still residing, and reusing it offers the advantage that it's non-intrusive, so you don't need to rip out the copper, you don't need to replace it with fiber, and especially, so if you are in multi-dwelling units, multi-tenant buildings, this might be bigger work. So from effort point of view, from the construction work, from pricing, from a cost point of view, I think it adds up if you're an owner of, let's say, 10,000, 100,000 condominiums, and you would change everything to fiber. Of course, there's a certain wish to maybe start in certain areas to convert it to fiber, but in other areas leave it untouched. Especially if you have very old buildings, this could end up in a mess. And the other point is, like FTTH, you often need to contact the customer in order to enter the premises. You need to drill the fiber in, and this is quite much work. If you don't have the personnel, what should you do? So this is an advantage for G.fast, reusing the copper infrastructure inside the building as well, by simply taking it and using G.fast. So G.fast, the method itself is well defined. We have the ITUT standards defining it. We have supporting BBF work like TR 301 describing it well, how to use it. The big advantage is that it's TDD, so time division, which allows to basically freely configure the ratio between up and downstream rate. And please note that here the picture are showing the aggregated up and downstream rate versus the loop length. So the aggregated up and downstream data rate could be up to 2000 megabit. So it's 2 gig for very short copper lengths. Here the graph starts at roughly 30-40 meters. And typically values are, you set the downstream value to 1 gig at least, and the upstream is the remaining, whatever can be achieved here with it. So it's not exactly symmetrical. You can do it symmetrical if you use lower bit rates, like for instance 500. And I should add that the technology used here is a G.fast 212 megahertz, which is more the most modern. There have been specifications for the double, for instance, 424 or 800 even, but they have not really become reality. In fact, the latest technology used nowadays is G.fast 212 megahertz. And the reason for this is of course, that copper itself has certain physics, and even with the highest effort, you could increase the rate, but then you have to spend much more power as well on the copper rate. So basically, G.fast 212 megahertz is considered as the most effective technology here for G.fast. So highest transmission rates on copper cables, triple play services are of course possible. The flexible customizable upstream-downstream ratio. And a big plus is as well that at the same time to G.fast VDSL2 fallback has been defined. So most CPEs are allowing to fall back to VDSL2, or in case of the DPU, DPU can automatically recognize if a VDSL2 device is connected, CPE is connected, or a G.fast. And this gives you possibility to install the G.fast DPU, but still have the customer be using the VDSL2 CPE. So how does it look inside the house, inside the building? There are different devices. Here I'm showing the typical devices that would be placed inside the building. So what we see in red is the fiber that enters the buildings. Then somewhere in the cellar or in the staircase, you have the wall mount DPU or a rack mount DPU. And then you have different sizes, different port numbers that can be supported. So typical units are 4 ports, 8 ports, 16 ports. There are even smaller ones with only 1 port. And there are also bigger ones, like here the rack mount DPU that can have 24 ports. And in some cases, you can stack DPUs together, achieving a 48 port G.fast system. So it's depending on the size of the houses, the number of rooms, the number of flats, the number of subscribers that should be connected. And then inside the customer flat, you have a G.fast CPE. On top of it, what you can do is as well, there you could put another wavelength on top of the data fiber here entering the building, which is a second wavelength with the RF overlay signal. And then of course inside the DPU you can have a optical to electrical converter, which is converting the RF overlay wavelengths to an electrical signal, so it can be fed in here into the existing in-house coax cabling. So it can enter the different flats via the normal coax cables that are already existing. So operators can provide at the same time here the RF overlay signal as well. there are plenty of CPEs connected here. I'm based in Germany. So here in Germany, we have quite much the AVM FritBoxes, but there are different styles. Now DZS has own CPE as well, but we see from other companies you can get as well CPEs. So typically what they offer is they offer the G.fast 212 megahertz support. They offer the VDSL2, even 35B. As a fallback option, and then they have different numbers of interfaces. Like here, in this case, it's 4 times 1 gig, or in this case, it's a more modern model. Here has 2 times 2.5 gig inside. The one model uses VLAN and wireless LAN with AC, Wi-Fi 7, Wi-Fi 6. And then, of course, depending on the legacy network here, you can have the support of different old legacy technology like POTS, ISDN, or DECT. So your old telephones can be connected, making it quite neat for existing customers.
We're going to have to speed it up a little bit to get within our time frame.
Okay.
About that.
Yes. The good combination is, of course, if you use the G.fast directly as PON only, and this can be achieved by having the MAC already inside the DPU, so you can connect it to either GPON or XGS-PON to your OLT and monitor this. And more important is the operational aspect that from a network management perspective, the DPUs are nowadays supporting NetConf YANG already. So here the Broadband Forum defined TR355 for FTTB management, and then of course for access networks the TR383 is used. So with a specific model here for G.fast, you can basically set all parameters and treat the G.fast DPU as well under the umbrella of the SDN controller, which makes it quite, and similar could be done then if you use simple copper lines, the classical Cat5, Cat6, Cat7 cables. Of course, depending on the speed, you need a certain Ethernet quality of the cable. But the big thing is then that all units should be capable to transition to SDN by supporting NetConf YANG, avoiding this classical style of vendor-specific management systems or proprietary SNMP provisioning, so that it's possible to control all the devices, no matter if it's a transport with WDM or the ONTs or the G.fast DPUs, up to the Wi-Fi with one multi-domain service orchestrator, and then having this multi-service orchestrator being part of the operations system inside the management systems here, and controlling the whole path from end to end. So to summarize here, important is in order to use FTTB as complement to FTTH, speed, low latency. That's the reason why we have chosen G.fast 212 megahertz, for instance, or in case of the layer 2 access switch, the 10 gig, for instance, high speed. Important is to follow open standards like defined by Broadband Forum, so that it can be used as an opportunity for shifting the ecosystem towards more modern methods, allowing the multi-vendor orchestration via SDN network controller. Often, and that's a reason for using G.fast, the copper or layer 2 access switches via the Ethernet cables infrastructure reuse. So you can manage the investments by using existing copper info, maybe saving some cost which you can spend at other areas, maybe where you are competing with competition. Important is to use mainstream technology, no login certain technologies, and the other thing is, of course, multiple form factors, multiple choice, so you can choose whatever is the best solution, but having everything integrated under one umbrella management system. Okay, that's what I wanted to show you